Alrighty, here we go.
And she had explained that she has 5 children and she's about to bring 3 international kids over to adopt them in summer.
Oh,
dude,
I heard about that.
And someone was like, "Why not adopt America?"
Yeah, because American kids need love too, and it's like.
My mom said they kicked her
True.
off the beach.
Oh my god, the whole Lincoln just jumped on her.
This is why social media is vile.
The lady said she was going to adopt.
But it was so bad. She was like, "You guys are bullies," and she's like, "You just said to adopt America because
Yeah.
you're wasting time going international."
Social media, great. Good stuff. All right, folks.
I love the moms on Facebook.
It's not moms. It's people. It's people on Facebook and Twitter and every other social media that you can think of. When you give people a slight bit of anonymity and a voice that can be heard by all, you just hear some really crazy stuff.
Tinder's where it's at, though.
Yeah, right. Yeah, Tinder's another fun one too. All right. Anyway.
Do you know? Do you speak from experience?
Do I speak from? No.
Whoa.
Thankfully, I was already coupled with someone before
High school sweetheart?
Tinder was a thing. So, anyway, moving on here. In this procedure, all right, we're going to continue our look at augmenting matrices and simplifying and all that fun stuff, okay, to solve massive systems of equations. Now, really, what we're doing here is something that people program computers to do, because obviously it's very tedious and there's lots of opportunities for mistakes, but computers are pretty good at not making mistakes as long as the person programming them in the first place does a pretty good job of it, right? So this is really something that computers would normally do, but we're going to do it because yeah, all right? So here we go. So we're going to solve the system of equations. Again, we're going to augment this, or create an augmented matrix here, so we'll just do something like arrows, I guess. So you all get that. 1, -2, 3, 9, -1, 3. There's no z term, so put a 0 for that second row. And then 2, -5, 5, and then the 17. Okay.
You don't put dotted lines next to your answers, and that really messes with my head.
What's the dotted lines next to my answers? What do you mean? Oh, like this you're saying? What's that? No, that's okay. I'll do that. I do that. I didn't. Yes, I will do
It's a
that.
solid line.
It is a solid line. But these are Mr. Goff's old notes right here, and he definitely used a solid line there before. So.
Oh yeah, Mr. Wade, how did
But
you
his
turn
new
that on?
note is all.
How did I turn this on?
Yeah.
I pushed the power button right there.
You're lying.
Mr. Goff spent
You're
like
like-
15 minutes yesterday trying to.
He's like, oh, it's weird thing.
Yeah, so then
He's like, we've got some trick to
we
it.
did all the notes on the board.
No, yeah, I saw when I came back. I was like, oh, that stinks. But anyway. It's the same story when I went to go to try and help teach some of his class, because he uses the Promethean board, and I was like, I don't even know.
He was like, oh, he's probably got some trick to it.
It's right. I don't want other people writing on my board, so I'm going to make it really hard to turn it on. No, it's just the power button right there. But it is in his defense, it is upside down. So okay. Anyway, though. So all right. Let's. So we already have a 1 in our very first row, first column. So that's great. And so we'll just do 1 times R1 plus R2. Right, to then get that 0, and then we'll do -2 times R1 plus R3 to then get 0 in the bottom row there. So let's go ahead and do that mental math here, and hopefully I won't make any errors. I now have a new respect for my old linear algebra teacher in college.
I have respect for your linear algebra teacher in college.
Thank you. Yeah. He appreciates that.
Oh my god.
1, 6 plus 1, 18, 17, 1.
The best day ever.
-1. Okay, so far, so good.
No, sir.
You got -9? Huh?
Oh,
This is right.
no, because I didn't realize that I put a negative. I didn't realize that.
And this is why nobody likes biology.
No, guys.
There's so many other
Summed up in a nutshell.
No. Look, it's all fun and games, and then someone goes too far, and now we have like a lawsuit on our hands, and people are kicked out of Facebook pages. Okay, so let's not.
Let's look on the bright side. We also have waffles.
Right. Belgian
Did you hear that
waffles.
IHOP changing its name to IHOB?
Yeah, international. Did you see the Twitter for it though?
House
Like,
of Breakfast,
after
is that what
60
it's
years of
for?
Pancakes. We're gonna go there
They're
and
flipping
flip
the P over.
That's dumb though, because they make a face with the current,
No.
and there's
So-
where's
so
the
it makes
nose
sense
gonna
it's
be?
Lowercase b. So
Yeah.
it would make the it would. It's,
Like the brow, I guess, or something.
Yeah, it would make almost like a line for the nose.
I guess. Okay.
Wait, IHOP makes
Oh, like a little line
Right,
because
so
of the
it'd be-
bottom.
so it'd be down, right.
Okay.
It doesn't make any sense whatsoever.
Mm. Okay, so next we're going to add row 2 to row 3.
Wait, how do you solve this?
Okay, because again we have 1 with zeros below it, so now we have a 1 here already, and we just want to get some zeros below it. So we're going to then continue. So again, keep 0, 1, 3, 5, and then 0, 0, 2, 4. All right, so you want the dotted line there. I'll put the dotted line there now. Now I understand. All right, and last up, we'll just do 1/2 R3. Yeah.
How do you solve it from here?
Or you could just solve it.
I'm going to run out of space. Maybe not. Okay. We got this.
Sean, there's
So 1, -2, 3, 9, 0, 1, 3, 5, 0, 0, 1, 2. Okay. Yes? Something like that.
Isn't that exactly what we've been doing?
So yes, with a but. We are not quite done yet. So what we're going to do, what we did here at this point is we stopped in the past, right? We said, okay, so we know that z then is equal to 2. We then use that z in this equation where we have 1y plus 3z equals 5, and then we use that to find y, and we plug the y and z back in here where it was 1x minus 2y plus 3z equals 9, and then solve there. However, we can continue with our matrix operations here. Let me show you what I mean. So for example, I can take, now that I have this row and row echelon form, I can take this 1 and eliminate this 3 here, right? Actually, I can eliminate backwards as well, right? So, and again, I'm using this particular row because it's got a 0 here, so it won't affect these two numbers at all, but I will get rid of this one and make it a 0. So what should I multiply this third row by to kind of get rid of this 3 right here? A -3, right. So I'm going to kind of go down here, if you'll permit me there, and we'll just do -3 R3 plus R2. And again, I'm choosing R3 because I want to have a 0 here still. I want to get a 0 here though, so that way I just have Y, right? I just have 1Y. Just like I have 1Z here, I'm going to work backwards, so I just have a 1Y, a 0X, and a 0Z there. Okay? So we're going to do that here. So my first row again stays the same. 0, 1, and then -3 times 1 is going to be -3, plus 3 will give me a 0 there. -3 times 2, -6 plus 5 will be -1. Okay, so now we know that z is what? 2, and we know that y is what? -1, right? Because in the second row, we've eliminated both the x and the z. And so we just have y as 1. And guess what? So now we're going to go back again, and we're going to use row 2 to eliminate this element, okay, of row 1, and we're going to use row 3, the 1 here, to eliminate this element of row 1. And we'll do it maybe like, I'm going to go backwards here, so I hope this doesn't like confuse people. We're going to go this way. Okay. So let me use row 3 again here. So again, to use row 3, I'm going to multiply row 3 by -3 to then eliminate that +3 right there. So we'll do -3 R3 plus R1. Okay. So we're kind of like eliminating the stuff behind here. So I'll still have a 1, I'll still have a -2, and then this will be now 0, and then -3 times 2 is going to be -6 plus 9 will be 3, and I still have the 0, 1, 0, -1, and then 0, 0, 1, 2. Like that. All right, and we're almost done. What's the last step we want to do here?
Multiply the middle row by 2.
Row 2 times 2, and then add to row 1. Exactly right.
1, 0, 0, 1.
And so exactly right. It'll be 1, 0, 0, and then 2 times that will be negative 2 plus 3. It'll be up 1, and then 0, 1, 0, negative 1, and then 0, 0, 1, 2.
And this is still inferring that you can actually like get like the first step.
And so x, the solution here is x equals 1, y equals negative 1, and z is 2.
What you have to do is you have to
So,
do negative 3 over 3.
all right. And so what we've created here, this form where you have 1, 1, 1 down the diagonals, and then 0 for the rest of the elements, this is called the identity matrix. The identity matrix.
That sounds
The identity matrix.
Okay.
Hold on.
Questions on anything so far?
What do you put in your hair?
What's that?
What do you use for your hair?
My hand.
What?
And shampoo. Shampoo/conditioner.
Me too,
Swab
actually.
for men.
2 in 1.
Yeah,
Those
yeah.
guys that
I'm not
like,
trying
wake
to.
up and your hair's already like fine.
For the most part, I mean, sometimes back here it's a little bit of a festival. Right now it's feeling a little poofy. I don't know what's going on back there.
Yeah,
But when I look in the mirror, what I see is all right at least. Yeah.
This morning I looked in the mirror and I was like, do I shower or is it fine? And it was fine.
Dude, you're making it
We're
worse.
making it worse.
Thanks.
It looks like Drew Dyer would be kids.
Anyway, yeah, I used to shower in the mornings, but then I got married and I was told that I have to shower before I go to bed.
I do
So
both.
that's what I do. Because it makes because if you get into the bed after a long day of being out and doing stuff and sweating, then the bed gets gross.
Oh, yeah.
And you want the
Yeah,
bed
that
to be
makes
nice and clean.
But
So.
then,
How about you take a shower before you go to bed, and then when you wake up too?
Yeah, I could do that too.
That's waste
that's
water.
waste the water.
Could be. Yeah. So, anyways, so this is called the identity matrix. We got x equals 1, y equals negative 1, z equals 2. And so there it is. Okay.
We did it.
We solved it.
I did it.
Okay? And then this form is called reduced row echelon form. Okay? It's
Or
just
easy form.
right.
When's our quiz?
Next week, I think Wednesday.
Perfect. That's had to be one day that I'm actually here.
Okay? Wednesday of next week. So, reduced row echelon form. Okay. So, let's go ahead and set up the matrix then for letter B here. Okay, so set up that matrix for letter B.
Matrices.
Okay, the augmented matrix here.
Okay, so how do we do it if it's not a square?
You only need 3 of them to align, so you have one that you just use to fix stuff, I think.
I'm going to use all 4 here. I would say, so I guess
Like, you only need to make like a diagonal with 3 of them, right?
Yes, we'll get to that in a second here. Yes.
Kurt, how do you know all this?
Because it's common sense.
Yeah,
common
I
sense.
don't have any of that.
We'll get to that in a second here. I guess I'll just go ahead and just do it here.
Mario, the only reason why you need 2,
Common sense.
3 is because
Sometimes
the fourth
ain't
one is
so
just
common.
another variable with the same letters.
Yeah, so if you get the 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, you have the answer.
The answer, yes.
Did anybody else just like listen to that? Just, like,
1 0 0 0 1 0 0 0 1. That makes sense. It's the
1 0 0 0. Okay.
the
It makes
reduced
complete
echelon
sense,
form.
guys.
We have to be
I
back
concur. It makes complete sense.
It does.
I get it.
I concur.
That's exactly
Okay, so again, we have we already have a 1 for our first row, so I'm going to go ahead then and use that first row to eliminate all the coefficients or all the elements below it. Right?
So wait,
Go
are
ahead.
we doing all of them or just like the 3?
I'm going to do all of them. And you'll see why in a second here. You'll see why.
Is there a difference?
Say again?
Is there a difference?
About like whether you do or don't?
Yes.
more to work with, so.
I think let's I see what you're saying. Let me just, you're going to see what's going to happen here in just a second, so I want to hold off on giving away too much. So let's just proceed as we normally would, trying to get all the zeros underneath and stuff like that. Okay. So again, I'll multiply row 1, -1, row 1 plus row 2, and then I'll do -2, row 1 plus row 3, and I'll do -3, row 1 plus row 4. Okay, again, just trying to get these things to cancel. And so then that becomes still 1, -1, 2, 4, and then minus will be 0, -1, 1, -2, -2 so -1, and then -4 will be 2.
Is that -1 times R1?
It's -1, yeah, times R1, yeah. And then -2 times R1 plus R3, and then -3 times R1 plus R4. Okay. All right. Back to my mental math.
That's my fault.
That's okay. My brain is not capable of much. I have to command it sometimes. I'll put it in at the end. -8, -4. Yes.
I just realized that Mr. Wiz never said that in class.
Said what?
Told you to get off your phone?
Yeah.
No, I kind of like, and to a certain extent, I believe you guys, you're old enough, and there's natural consequences to being on your phone all the time. So,
Especially in this class. Yeah.
but I feel like I sometimes could do a better job of reminding you, hey, if your grade is not where you'd like it to be, consider putting that phone away and paying better attention. Maybe I should do that too. Well, there you go. So, if you're satisfied,
Wait, you got it?
-6 plus 1.
If you had to use my phone, I would have gotten a B.
Yeah, because you don't need all 4. So once
Actually, so one little tidbit of information I learned was at Linganore next year they are banning cell phones in the classroom, and so you'll have 2 options. If you don't put your cell phone away, like when the bell rings, option 1 you can choose to take your cell phone down to the front office and leave it there. Or option 2, you can put it in one of those bags that they use at concerts now. Are you familiar with these? What's that? They're like some sort of like bag that you can lock with like a lock or something.
We're talking about like a deposit.
No. In classroom, like but between classes is fine. But like when the bell rings for class until the bell rings after class.
And
At the
they're
end of
not
class.
looking at it at Oakdale?
5.5.
I don't know, but they piloted it at Linganore a few classes, and they're going to use it for the entire school there because they had some issues and stuff like that too. Although of course we've had issues here with cell phones too. People at Linganore were apparently like putting their phones in those like even like the shoe things that some teachers use, and then like leaving their camera on record and then doing stuff in the classroom and all that. So the principal there was finally just sick of it. And of course,
Dude, that's a fantastic idea.
I hear of other stuff happening in classrooms here. And I'm like, this could happen here at some point too. So.
I don't care if they do it, but I'm glad that they're not doing it next year.
Right. Well, that remains to be seen.
We
So,
don't know that, Mike.
yeah, it could happen still. So, anywho, here we are. We're going to continue on. Right, we have the one that we want, and so we'll go ahead and add row 2 plus row 3 to cancel out there, and then we'll do -5 row 2 plus row 4.
So if I'll get in this format,
Okay, so we'll still have the 1, -1, 2, 4. We'll still have the 0, 1, -1, 2. We'll still have the... You got a half somehow? Okay, I would say go back and check your math because I definitely know this matrix is right. So say check your work there. Oops, this is now a 0. And this is now a 0. And then this is 2 plus -4, so -2. Okay.
Is that a -5 times R2?
And that's -5 R2, yep, plus R4. And again, yeah. And so we get 0, 0, and then -5 times -1 is 5, 7 is -2, and then -10 minus 11 is -21. Okay, so
So is 0?
we see something interesting, right? We see something interesting happen here, right? Okay, we have a row full of zeros. But it's not full of zeros, sorry. So we have 0x, right? What is this row saying with our kind of elimination we've been using here? We have 0x plus 0y plus 0z equals what?
-2.
-2. Okay? So again, we've got 0x plus 0y plus 0z equals negative 2.
That means that you have a negative 2 to start with.
Well, right. So there is something funny here, right? So what is 0 times x?
So I got the 0.
0.
It's 0, right? And 0 times y is 0, and 0 times z is 0. So we have 0 plus 0 plus 0 here. We're saying this.
So the y-intercept is negative 2.
The y-intercept is negative 2.
That's undefined.
Right, so you guys remember back when you first learned how to solve systems of equations, okay, you stuck with just 2 and you used like substitution, graphing, elimination, stuff like that. And every once in a while you'd run into a situation like this, and what was the conclusion that you would draw? Not a hole. What's that? No solution. Yeah, no solution. So there is no solution. There is no solution to this system.
Which one?
Wait, the whole thing?
The whole thing.
Because there's one hole?
Sean, it's a system.
There's no solution. Right. If one of them fails, the whole thing.
Imagine you're going through all this work and then you get to the fourth row.
For
and
part
it's
B,
0, 0,
this
0.
system has no solution.
That's a slice.
There's no one solution, or not. There's no solution that you can pick that will match all four of those. That will make all four of those equations
So Mario,
true.
think about it at the same time. What if you're all the way, you do all that work and then you just have to stop, like you're done?
Yeah. The nice thing is, yeah. I mean, look, this was a lot of work right here. We kind of were able to stop right there. Okay. And
it's the same thing for 0 equals 0, right?
same thing for 0. No, 0 equals 0 would then be the like an infinite number of solutions or something like that.
So
Kind of
then we
thing.
just put infinite solution.
Right, and I'll show you here. So I just showed you a no solution, right? So let's take a look at the next one. Okay.
Yeah, that looks like.
So, and again, you can also see something unique here too, all right? Because there's another kind of principle when it comes to solving systems of equations where if you have 3 variables, what's the minimum number of equations you need to solve a system with 3 variables?
1.
You're going to need 3 equations. You really need 3 in order to get a unique solution. A unique solution, I should say. Okay, I say unique. You're right. You could come up with some with just 1, I guess. But maybe I shouldn't. Maybe that's not true. No, I want to be careful about that because you think you might have a point there, Michael. There might be more than 1. So
That's what I was thinking.
I'll stop. Right, of course. So anyway, let's just continue on, and I'll just stop talking. All right. So we'll create another augmented matrix here. 2, 4, negative 2, 0, 3, 5, 0, 1. Okay.
We do an example 3 in our own.
I'll get you to the setup point, and then I think you'll kind of figure out what to do from there. It's not that bad, but let's continue from here, right? So what would be a good first step for this matrix right here? Maybe first step. Yeah. The first row, let's divide that by 2 so we can get that 1 that we need. Okay, so 1/2 R1, we'll get then 1, 2, negative 1, 0. And then that's 3, 5, 0 to 1 there. Okay, and then what's our next step going to be?
Negative 3 R1.
Yeah, so negative 3 R1 plus R2.
Wait, what's going on? How come strategies aren't working?
2, negative 1, 0. And so then we get 0 there. Negative 6 plus 5 is negative 1. 3 plus 0 is 3. Wait.
I don't know how am I supposed to solve this.
Okay, that's right. Okay. And then negative 3 times 0 is 0 plus 1 is 1. All right, and then I multiplied by negative 3 when I should have multiplied by... Wait, what did I do? Did I do something weird here? Negative 3 times 2 is negative 6 plus 5 is negative 1. Yeah, okay, that's right.
Then you multiply R2 by.
Oh, I see what I did now. And then we'll multiply R2 by negative 1. And so we get 1, 2, negative 1, 0, 0, 1, negative 3, negative 1. Okay. And then again, we'll work backwards, right? We'll get into that like reduced row echelon form if we can. So we'll also then do negative 2 times R2 plus R1, right? So we'll do negative 2 R2 to then eliminate that 2 that's above it right there. So we get 1, 0, let's see, 6 minus 1 is 5, and then 2 plus 0 is 2. And then 0, 1, negative 3, negative 1. Like that. Right, so we have a problem here though, right, in that we don't have a third equation or a third row to then, get a 1 in it and then use it to eliminate the 5 and the negative 3. So at this point, we're kind of like we've done as much as we can. So what does this mean, right? Well, let's put this back into our more familiar equations here. So this top row would indicate we have 1x plus 5y, that's equal to 2. And then we also simultaneously have then 1y minus 3z equals negative 1.
5z.
Oh, shoot. I messed up my... Yeah, sorry about that.
3z.
You're right. It should be x plus 5z equals 2 and y minus 3z equals negative 1. Okay. And so with a result like this, and let me do one more step here to maybe, I'm just going to go,
Wait.
question?
Why is it?
All right, think about your question. Let me know here. I'm going to keep going here because I want to make sure I get through everything we need to get through today. So 2 minus 5z, and then y equals negative 1 plus 3z like that. Okay. Now, if you notice this, we have an x in terms of z. We have a y in terms of z. Okay. This kind of looks like stuff that we've done in the past, right? Where in the past have we had x in terms of a variable and then y in terms of that same variable kind of thing? Parametric. Okay, yes, exactly, with the t's, exactly right. So in this case, our parameter is z, okay? Or if you really want to, you could say, let me go this way over here. You could say that x equals 2 minus 5t, y equals negative 1 plus 3t, and then z would just be equal to t. Okay? Now, with that understanding, right, there's no one solution here. There's an infinite number of solutions. You can just pick z to be whatever you want.
Like a billion.
Right, you can pick z to be like a billion, and then y would be 3 billion. So, oh gosh, it'd be 2,999,999, right? And then negative 5 billion plus 2. I'm not going to do that. You get the idea, right? Okay, negative 5 billion plus 2. Negative 4,999,998. Okay. But you get the idea here is that this, then, how many solutions are we going to have? Infinite solutions. We have an infinite number of solutions here. Okay? Because x and y are dependent on z, and z has no stipulation. Z, it can be whatever you want it to be. Z can be whatever value, and then we will get x. The matching x will be then 5 times that, so 2 minus 5 times that z, and y will be negative 1 plus 3 times that z.
So if you get a mathematically incorrect solution for one of your variables like that, like the previous example with 0 equals 2, it's no solution, and
Correct.
If you get an unsolvable
Nailed it.
equation,
What's that?
and if you get a non-distinct algebraic solution, it's an infinite solution.
Yeah, when you end up with something, here where both x and y are dependent on the variable z, and z has no stipulation, z has no rule for it, then z can be whatever you want, and so then x and y resultingly would kind of be. Okay. So infinite solutions. All right. One more here.
Is this the last one for today?
No, we're going to do matrix multiplication too real quick as well. But I'm just going to set this one up. I'm not going to have us actually solve it. I'm just going to have us set it up, okay? Because we can solve it. I have faith. So, but the setting up is a little bit tricky because we're twisting here, or being asked to do. So number 3 says use a system of equations to find the quadratic function f of x equals ax squared plus bx plus c that satisfies the equations using matrices. Okay, so just like it takes 2 points to define a line, right? You need 2 points to define a line. You need 3 points to define a parabola. Okay, so there are 3 points.
That's how we do it.
How might we set up a system of equations here, Sean?
So we plug each of these in.
Okay, so what would be like one equation I could write here?
So it could be like 8 is equal to a minus b minus plus c.
Maybe minus c because we plus negatives. Oh, I see what you're saying. You're right. Plus c because of the thing. Yeah, you're right.
There's no x.
You're right. Yep. Very good. Okay, so did you see that? So what did Sean do here? So we know that this function in the generic ax squared plus bx plus c format, right? We want this point to work. So he put 8 in for y, he put the negative 1s in for x, and then simplified the negative 1 squared would just be positive 1, negative 1 times b would be negative b. And so there's our first equation. And so we do the same thing then for these other two. So then we would have also 2 equals a plus b plus c, right? And then 4 equals 9a plus 3b plus c. And so then we could, go 1, negative 1, 1, 1, 1, 1, 9, 3, 1, and then 8, 2, 4 over there. And then solve this augmented matrix.
You don't have to do that. That's okay. You don't have to do that.
More homework. Yay.
Really, it's okay.
Okay, and I'm going to leave that for you guys because I want to move on to matrix multiplication.
If we burn it.
Okay, so dot, dot, dot.
So wait, do you want me to open this?
Anyway, you get out.
Sure, yeah, he'll be able to find the error, I'm sure.
Mr. Goff, would you like to look for an error?
Yeah.
Okay, so again, you guys can solve from there. Easy peasy.
Mr. Goff.
Get the
I
idea.
have no idea how you just got that, Mr. Rid.
Which one?
The 8 equals a minus b plus c.
So again, the idea is we're trying to come up with a quadratic function like this, right? And we want these 3 points to work in that quadratic function. So we're going to just take the negative 1 and 8. Okay, 8 is the y coordinates. That means it would have to go in for f of x, right? It would be 8 equals, so 8 equals. And then negative 1 is the x. So negative 1 squared would be 1, so it's 1a.
Okay.
And then negative 1 times b, negative b. And there's no x for the c, so you don't plug the negative 1 in here at all. It's just going to be plus c. And so we create this equation. And then using this point, you create this equation, and then this point using this equation.
Okay.
So, we're good on that?
Yes, sir.
All right, any other questions there? Because again, I'm not going to finish it off. You guys know how to do that from there. Let's move on here to then matrix multiplication. Okay, and I think, crikey, okay. Goodness gracious. Yeah, okay, so here we go. Matrix multiplication. So again, this is a basic,
So this one's okay.
this is basic matrix arithmetic, right? So you guys know how to add matrices together. It's just corresponding elements get added. Subtracting matrices, corresponding elements get subtracted. And then there's the scalar multiple. So if you put like a 2 in front of the matrix, then everything gets multiplied by 2. Multiplying matrices, though, is a little more complicated. Okay? So let me just show you here. All right, we'll just get into it. So we're going to multiply A times B here. So we've got a 3 by 2 matrix here. And we'll multiply that by 2 by 2. And again, it's rows by columns, right? When you describe the dimensions of a matrix, it's rows by columns.
What?
Okay. So, the way that we multiply here, okay, the way that we multiply here is that each element in your row from matrix A will multiply to the corresponding element in the first column here. Okay, so negative 1 and 3 are going to multiply with negative 3 and negative 4. Okay, just like that. So let me show you what I mean here. So AB is going to equal negative 1 times negative 3 plus 3 times negative 4. This is homeworks.
Yeah, those 3 plus there are
Tonight.
2. There are 2 on 8.1 that they.
2 and 8.1 as well.
Yeah, they did 3 of 5. So they
Okay. They were asked to do 3 of 5, or okay. So finish the other 2.
Wait, did you get to a point where this matrix is mountains?
Which one? From the previous one that I gave you? I can take a look at that right now, but or not right now, but I will take a look at that later if you want me to. Yeah, sure. So again, you see here, negative 1 times -3, 3 times -4, right? So that's the first element there of AB. And then for the next thing, we'll do this row, -1, 3, times this column, 2, 1. So -1 and 3 times the 2, and then the 1 there as well, like this. So it's going to be -1 times 2 plus 3 times 1, like that. Okay, so row times the first column there gives us the row 1, column 1 element, and then the first row times the second column give us the first row, second column element in AB, the product matrix there. Okay, so again, the -1 and the -3, and 3 and the -4, right? And then the -1 and the 2 and the 3 and the 1.
Why do you keep saying the size of the blind?
Okay.
That's fun.
Okay, so then we'll do the next row, right? So 4 and -2, so row 2, again, times column 1 here. So it's going to be 4 times -3 plus -2 times -4. Okay, and then 4 times 2 plus -2 times 1.
It'd be like negative.
And then 5 times -3 plus 0 times -4. And then 5 times 2 plus 0 times 1. Okay. So what will our solution matrix, the AB product here, what dimension will our solution matrix be here? 3 by 2, right?
Is it 5 times -3?
5 times a 3 right there.
Oh, right, or just a straight 3?
Or it should be, wait, you're right, it should be 5 times -3, you're right. I must have not written it. Yes, it should be 5 times -3. Yes.
No, don't worry about it.
Thank you, Michael, for correcting me. Right? Which is then equal to when I simplify here, right? So 3 minus 12, -2 plus 3,
Wait, what?
-12.
Wait, what did you do for
-12
that
minus 8,
one?
-20. This one right here?
Yeah.
Row 2 times column 1. So 4 times -3, -2 times -4.
Oh, -2 times -4.
Mm-hmm. Yep, and then 8
Wouldn't that be
minus
negative? Wouldn't that be
6.
negative? Or negative?
Oh, wait, that's a -2 times -4. So wait, yeah, it'd be -4.
Yeah, negative 4.
-4. Yep. Okay, and then -15, and then 10.
I'm starting to get this.
Okay, good.
What would we do with the
You can use simple arithmetic. I'm so proud of you, Sean.
Say one more time, sorry.
Like, what would you do with the answers if, like, there's an equal sign to them? Like, when we have matrices, it's like, we have the 3 by 3 and the 2, right?
Oh, an augmented matrix, you mean?
Yeah.
Okay, right. So, you would, like the dotted line, we just kind of put in there to differentiate things for our own purposes, but if it's just, you treat it like a normal matrix kind of thing. Yeah. Okay. Like I could throw a dotted line in here and you still, just do the same thing almost. So, yeah. Okay? So there's our solution. Now, we did A times B, right? So we had to do row times this column, row times, row times column 1, row times column 2, and all that stuff. But now let's do BA.
Isn't it the same thing?
Okay, well, that's a great question, right? Because, like, in arithmetic, for example, we have 2 times 3, and that's the same thing as 3 times 2. But now, is it going to be the same thing with matrix arithmetic, right? With matrix operations. So right, it's in fact not going to be. So let's follow the same procedure that we did, though. So in this first one, we did the first row, right? This one times this first column here. So let's do the same thing. So first row times first column. So we'll do again B. Oops, we're doing B times A. So sorry, I have to go. Darn it, it would have been really nice if we had done this, flipped around the matrices. Anywho, so we're going to do the first row here, -3, 2, right, times this column. So again, it's kind of like, you got to think a little, just be careful here. So it's,
You're gonna be like a lot more.
from the first example, we did A times B, so it was the row times the column. So now we're doing B times A. It's got to be B's first row times A first column. What's the problem? There's another number here, okay, right? We have 2 elements in this row that we want to multiply. So like the -1 and the -3 pair up, the 4 and the 2 will pair up, but then 5 has nothing to pair with. Can we just throw a 0 in there and say it's okay? No, okay? And so in fact, we cannot multiply these two matrices this way. So A times B, possible. B times A, not possible. So, go ahead.
It's not possible now, or is it like never possible?
Good question. Good question. So what is the scenario here? So in this case, in this problem, we did a 3 by 2, and we multiplied that by a 2 by 2. Okay? And what was important here is that these two matched up. Okay? But then when we do this right here, these two do not match up. Right? We had 2 elements in our row trying to correspond with 3 elements in our column. Whereas here, we have 2 elements in our rows matching 2 elements, right? 2 elements in our rows matching 2 elements in our columns like that. So the order, right? Because this was matrix A's dimension, this was matrix B's dimension, and this is matrix B's dimension, this is matrix A's dimension. And so since these match up, we can see that this matrix arithmetic will work, whereas these do not match up, and so this matrix operation is not going to work. Does that make sense? Yes?
Yeah, but like, are we ever
So-
going to learn how to do that?
No, in fact, it's not possible because there's just no element there to complete the matrix multiplication with.
So this is another one that you want to.
You want to see these, exactly right. Yes. So yes, exactly right. Because like, I don't have to do it.
So a quiz full of those.
Okay. Yes. Right. So notice also here that when we did A times B, again, it was a 3 by 2 times a 2 by 2. The 2's matched up, so again, that leads to conclude that we can multiply here. And what was our final matrices dimensions? It's 3 by 2, which is the remaining 2 numbers here, 3 by 2 as well. So these remaining 2 numbers, okay, that's going to be your new kind of dimensions as well. Okay, so anywho, let's continue on. Go back. Don't understand what? What's the trouble? Do you understand why it's not possible? Why B times A is not possible? Shh. The first one is possible because of how we do matrix multiplication. When you multiply A times B, you take the first row of A and multiply it with the first column of B. First row times first column. Okay, right? And there are, each element in the first row has a pairing element in the first column, so we're good to go. And then each element in the second row has a pairing in the first, again, they all can match up. But then here, when we do B times A, if I do the first row of B times the first column of A, I have 2 elements in the first row of B, I have 3 elements in the first column of A. So they can't all be paired up to multiply.
Okay, so for B you use the row and A you use the column?
For the first matrix, you use the first row, you use rows. For the first matrix, whichever that is, it's the rows. And the second matrix is times those columns then. Okay? So since we switched the order here, since B is first, we're going to use B's first row times A's first column to try and multiply, and you see we run into a problem because there's 2 elements and 3 elements.
The little ones first is possible.
Okay? All right.
This row, this row,
So
that, and
it's kind of like FOIL, yes. All right, so now we're going to take A, which is dimensions of what? For example 3 here. 3 by 1, right? 3 rows, 1 column. And what's B's dimensions? 1 by 3. Can these matrices be multiplied together in this way? Yes, right? We're going to create that. So we'll do A times B. So we'll do the first row of A, which is what? 7 times the first column of B, which is 1. So 7 times 1, 7, right? Then we'll do the first row of A times the second column of B. So first row, second column, 7 times negative 5, negative 35. Okay? And then 7 times 2, 14. So row 1 times column 1 becomes the row 1, column 1 element. Row 1 times column 2, row 1, column 2 element. Row 1 times column 3, row 1, column 3 element. Okay? What dimension of a matrix are we going to create for our solution here? 3 by 3, exactly right. So 11 will multiply with the 1, the negative 5, and the 2. So it's going to be 11, negative 55. What's that?
You made your line system.
I know, I did. I kind of shot myself in the foot there, but that's okay. -3, 15, and then -6. An imaginary math gun. Yes.
I probably shouldn't say that.
Yeah, I didn't even hear it, so it's on the recording. I'll listen to it later. I'm sure it was offensive. So, no, I'm just kidding. No, I'm just kidding.
I was like,
I'm just kidding.
you responded.
Okay, wait. So is it row by column or column by row?
So the first matrix that you multiply by, the first matrix in the product is the rows, and then you multiply those by the columns.
Right. So then 3.
Okay. So we created a 3x3 matrix from our 3x1 or 1x3. Now let's multiply the other way, b times a. Okay. Can we do b times a here? Will that work too? It'll be a 1x3 times a 3x1.
Yes.
They do, right? The rows and columns are going to match. Okay, the rows from the... well, anyway, yes, they do work. I don't know why.
So you multiply every single number, right?
So right, it's going to be like... let me see if I can do this right here. So B has one row right here. And then each element of that row is going to multiply with the first column elements. So it'll be 7 times 1 plus -55, -5 times 11, and then plus 2 times -3, so -6. And so these all get added up. And so we end up with -61 there, plus 7, -54. Single element matrix, a 1x1 matrix.
Wait. Wait, how did you get that again? So you just multiply
Because
by 1?
this row multiplies to this column, right? We're going backwards, so it's this row times this column. So
Right, so it's the
1,
first
7,
row.
-5, 11, 2, -3. And there's
I don't
only...
understand why this all is.
I mean, I can't really prove it. I can just say that is
How you do
the
it.
process, yes.
Mr. Wade.
So, question?
I have a question for you. So you say it's the first row for like that. So A is the first one.
So you're talking about this product right here.
yeah, so it's gonna be the first row.
So first row of A times the first column of B. So 7 times 1, 7.
Okay.
And then the second, and then you can do, you can go two ways. You can go across the rows like this, or you can go down the columns like this. It's your choice.
So you still have to multiply everything.
7 times 1, 7 times -5, 7 times 2. Because it's row by column 1, row by column 2, row by column 3. Okay? And then row by column 1, row by column 2, row 2 by column 3. And then row 3 by column 1, row 3 by column 2, row 3 by column 3. Okay? Okay. And the last thing here, we're talking about an identity matrix. Okay? I'm not going to bother with this because, well, I mean, I'll just talk about it. But a square matrix, n by n, that consists of ones on its main diagonal and zeros everywhere else is called the identity matrix and is denoted by I sub n. Okay? So, we're asked to multiply A, this matrix A here, by I sub 3. So what would I sub 3 look like? I sub 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Yep, just like that. Okay, now, it's called the identity matrix. So if you take a matrix and multiply it by the corresponding dimension identity matrix, what do you think is going to happen? You're going to get the same matrix. Exactly right. So I'm not even going to bother multiplying out. You can if you want to, but A times I sub 3 is equal to A. Okay, and that's what we're going to get. You're going to get the same answer here. Okay. If you do, row by column, row by column, row by column, you're going to end up with the exact same thing. Okay. So that's it. Okay. So, from my understanding, the homework, actually I know we only have 5 more minutes, but the homework is, you had homework last night that you had to pick 3 out of 5?
No, he gave us 3.
He gave you 3 out of the 5 that were circled.
Like, yes.
So you need to finish the other 2 then. Finish the other 2 there.
Wait,
And
and we have another worksheet?
yes.
That's not fair.
You said there's never been more than 4.
More than 3.
And so then here's this paper. Let me just start. And then the circled one's here. So there's gonna be 3.
That's another 3.
So it's 5.
So it's
More than
5
four.
total. 5 total.
He said no more than 4.
I don't know.
Oh, I didn't know you hated
Hold
us
on,
actually.
hold on.
Mine.
Take that up, Mr.
You said no more than 4.
Okay.
I like throwing
Finish
the
the
blame
other
about
2,
this many
please.
problems.
Finish the other 2 in your home.
All I know is I'm only doing 2 on the same worksheet.
Oh yeah, were we supposed to bring in our books?
Say again?
Were we supposed to bring in our books?
Here.
Yes, I will take your books back.
Go to the curtain.
If you like.
I don't have it.
We'll just specialize in different things.
We have 2 on
I
the
need to be good at everything. I want to be good at this. I need to get good at this. Sure.
Yeah, it's not tennis.
Now is this right? Or do my roads need to look exactly like that?